If you have Crohn's disease or ulcerative colitis, here's one of the biggest misconceptions I see. Most people think inflammation causes strictures. It doesn't. Inflammation starts the process, but scar tissue is created by an entirely different repair mechanism, and one forgotten immune cell may be controlling far more of that process than we ever realized. Stay with me for the next few minutes because I'm going to explain one of the most fascinating discoveries in inflammatory bowel disease research, and why understanding it could completely change the way you think about Crohn's and ulcerative colitis. By the end of this video, you'll understand why inflammation and fibrosis aren't actually the same thing, and why one overlooked immune cell could become an important piece of the puzzle in understanding long-term bowel damage. I'm Rachel, and I help adults living with Crohn's disease and ulcerative colitis restore their digestion, regain their energy, and rebuild trust in their bodies again. That work is deeply personal because I had to overcome my own mast cell activation and chronic gut inflammation. It completely changed the way I think about digestive health. Now I'm passionate about translating the latest IBD research into plain English, so you can better understand what's happening inside your body instead of feeling overwhelmed by confusing medical jargon. Every video I share gives you one practical insight that helps you understand your condition on a deeper level. One of the biggest fears for people living with inflammatory bowel disease is developing scar tissue. For people with Crohn's disease, that scar tissue can eventually narrow the bowel, creating what's known as a stricture, and in some cases leading to surgery. And what's confusing is that this can sometimes happen even after inflammation appears to improve. For years, researchers believed fibrosis was simply the inevitable consequence of inflammation. More inflammation meant more scar tissue. Simple. But we're beginning to realize the biology is much more complex than that. Most people understandably focus entirely on reducing inflammation. They're watching their calprotectin levels, looking at blood tests, waiting for colonoscopy results. And don't get me wrong, reducing inflammation is incredibly important, but it may not be the whole story, because inflammation and fibrosis are related, but they're not the same process. Think about cutting your finger. Your body repairs it. A small scar forms. Now imagine cutting that exact same spot every week for several years. Eventually the scar itself becomes thick, stiff, and inflexible. Your bowel behaves in a very similar way. Inflammation causes the injury. Fibrosis is what can happen during repeated attempts to repair that injury. And this is where today's story gets really interesting. Let's talk about one of the immune system's forgotten cells. They're called mast cells. Most people only know mast cells because of allergies, hay fever, food allergies, histamine, but they're actually some of the immune system's first responders. They're constantly monitoring your gut for anything that looks dangerous. Normally, that's exactly what you want. The problem comes when they stay activated for too long. When mast cells become activated, they release dozens of chemical messengers. One of those is called tryptase. Now, don't worry too much about remembering the name. What's important is what it appears to do. Your body has specialized repair cells called fibroblasts. Think of them as builders repairing damaged tissue. Research suggests mast cells may be telling those builders to keep working long after the repair should have finished. Instead of laying down the right amount of collagen, they just keep building. Little by little, more scar tissue accumulates. When scientists examined bowel tissue affected by fibrosis, they found something fascinating. More mast cells, more tryptase, and more collagen. Animal studies found that removing mast cells reduced fibrosis. Adding them back increased fibrosis again. Researchers have also shown that blocking tryptase can reduce fibrosis in experimental models. Now, that doesn't mean we've found a cure, far from it, but it tells us mast cells may be far more than innocent bystanders. They may actually be helping drive the process. So why does this matter? It's because once you understand that inflammatory bowel disease isn't driven by one single pathway, everything starts making a little more sense. Your immune system isn't just switched on. It's an incredibly complex network of cells communicating with one another. Some protect you, some become dysregulated. Some can unintentionally contribute to long-term damage. Mast cells appear to be one important piece of that puzzle, and every year researchers are uncovering more about how those pathways interact. One of the reasons this research resonates with me so much is because I experienced mast cell activation myself. Rather than only asking how I could suppress the symptoms, I became fascinated by what was keeping those mast cells activated in the first place. As I addressed those underlying drivers, my own mast cell symptoms disappeared, fully resolved. That experience completely changed how I think about chronic illness, because symptoms rarely appear out of nowhere. They're usually the downstream consequence of biology that's been pushed out of balance. And that's why everything I teach starts with understanding the biology first. Because when you understand what's driving your Crohn's disease or ulcerative colitis, you're in a much better position to support your body than if you're simply chasing symptoms. I hope this helped you understand why inflammation and fibrosis aren't exactly the same thing, and why mast cells are becoming such an exciting area of research. We still have so much to learn, but every new discovery helps us better understand the incredible complexity of inflammatory bowel disease. And the more we understand the biology, the more empowered we become to ask better questions, make more informed decisions, and work with our bodies rather than against them.